Hi students, let's look at this question here which is on vectors, which was taken from one of the tutorial questions from ACJC, I believe. So given that L has an equation of r equals to 3, negative 4, 7, lambda is negative I3, negative 2, find the position vector of L closest to the point P on L, on the line L, closest to point P, hence show the shortest distance P on the line L is root 3, okay. So we want to find the position vector of, okay, great. So this case here, just draw it out. I think now you have a line L as such. So this is line L. Just draw a line L. I would suggest writing so this line L here, I'm going to write it out as L, R equals to 3, negative 4, 7. And this is lambda. Negative 1, 3, negative 2. Well, this is lambda equals to root value, right? So I like to write it in this vector, column vector form because it's easier. So this case here, once done, we're going to put a point on this. This is 3, negative 4, and 7. And then this line, this direction here will just be negative 1, 3, negative 2. Okay, this is L. So maybe just label this as L. Then after which we're going to put P, which is 0. So P is here. P is actually 0, 1, 2 here. And now we need 0, 1, 2. And essentially what we need now is a point, position vector of point on L such as closest to P. So closest to P will mean that we are going to look at this footer perpendicular here. Okay, so that's what we need to find. Alright, that's pretty okay. What we need now is essentially just put, so remember, because F is on the line equation, this lambda is like a housing address, okay? So every point on the line will have a different lambda. It's like you give me lambda equals 0, I know that it will correspond to this point here. Lambda equals to 1, maybe it's here. Lambda equals to negative 1, maybe it's here. I'm not sure, I'm just guessing. But so now the question now is, what is this lambda here? Because once we have the lambda, we can sub into the line equation and we can actually find the point there. Okay, so what we're going to do is actually for some lambda real value here, we know that OF would just be equals to 3, negative 4, 7 plus lambda negative 1, 3, minus 2. Okay, so for particular lambda, it will correspond to that point there. Then because I know that this is 90 degrees, what I can do is actually just PF dot with D, which is this direction here, direction vector here, will be 0. Okay, the direction of PF dot with D will be 0. So this case here, we take OF minus OP. And this would just be negative 1, 3, negative 2 equals to 0. Right? So just take OF. So now we have got 3, negative 4, 7. This is our OF plus lambda. Minus 1, 3, minus 2. Minus OP, which is actually 0. 1, 2. And that will be negative 1, 3, negative 2 equals to 0. Alright. Then what we're going to do is just dot them. So before that, I'm just going to 3 minus 0 will be 3. Minus 4 minus 1 will be minus 5. 7 minus 2 will be 5. This will be lambda. Minus 1, 3, minus 2. And then I'm just going to dot this up. Okay. Typically, this is how I dot it. Just dot this. This vector, this column vector dot with this. Then that will give me negative 3 minus 5, negative 15 minus 10. Then plus lambda. Then we're going to dot the other one, which is actually dotting this here. Then this will be 1 plus 9 plus 4 equals 0. Okay, that's about it. So key in calculator, I think you'll get a lambda there. The lambda there would be negative 3, negative 15 minus 10. That will be 28. So this is 14 equals to 28. So lambda 28 divided by 14, that will give us 2. Okay, so if lambda is 2, we could find OF then, which is actually OF, which is the point. So hence OF, OF is equals to, just sub back lambda into the line equation here. 3, negative 4, 7. So 3, negative 4, 7 plus 2, negative 1, 3, minus 2. Okay, that's about it. Key in calculator will give us, this is 1, 6, this is 2, this is 3. 1, 2, 3. Such a nice number. Alright, so we got the, what do they want? They want the vector, position vector. So hence the position vector is this. Okay. This position vector of OF. That's about it. Great. So that's the photoperpendicular here. Hence, so once we're done, we find F already. Shortest distance of P to line L is √3. So this case here, shortest distance from P to line L. So hence, shortest distance from P to L, to line L, that will be, there will be just the distance of PF, right? Because that's the photoperpendicular is equals to modulus of PF here. There you go. So what you're going to do is actually just take OF, which is 1, 2, 3, minus of OP, which is actually that will be 0, 1, 2. Now this question here is a show, so I think by showing you, like, you already know that yeah, there you go, your answer will be correct here. So once it's correct, then it's quite reassuring. So it's √3 units. Okay, so that's about it. So I think the shortest distance done. That's how you do the first part. Let's look at the second part, which is find the position vector of mirror image of P when P is reflected in the line of L. So if you want to find the mirror image, what we need to do is you need the photoperpendicular here. Any kind of mirror image, we use the midpoint theorem, because as long as your what do you call it? As long as the distance between you and the mirror and your image is just of the same distance, then we will use mirror image, right? So this case here, what I'll suggest is just just maybe draw another triangle if you are not very confident at first. So this is a midpoint here. So we know that this will be F, this will be our P. So F is actually 1, 2, 3. P is actually 0, 1, 2. Then after which we have got P prime, which is the other guy at this side here. Okay, so we need to find that. So this is what we're going to find. So by ratio theorem or midpoint theorem, okay, the middle guy is always so this is 0. The origin here is 0. The middle guy is always the subject. So from here, what I can do is just OF is equals to OP prime plus OP divided by 2. So OP prime is what we're going to find is 2OF minus OP. Okay, 2OF is actually just 1, 2, 3 minus OP 0, 1, 2. That will be 2, 3, 2, 3, 4. What do they want? They want the position vector. Okay, so that will be a position vector, which is that P, yeah, that will be the position vector of the mirror image of P. Point P prime be the mirror. Yeah. Let's look at the last part. So let's look at the last part. The line M is parallel to the vector line 3i minus 5j plus 5k and passes through the point P. Find the equation of the line obtained when line M is refracted about L. So the thing is, it will pass through this line here, and that's the line L. But the thing is, I do not know whether it intersect L or not. So I think the first thing I will try and make sense is whether this line would intersect, whether it intersects or not. Okay, because if it does intersect, then it's easier to find the line of intersection. I think if it is a skew line, it's gonna be hard. I think it's a bit difficult. I'm not sure whether is it even possible to find a line of intersection if it's a skew, but we want to find where it intersects. Okay, so that's the main thing. This part here, what I'm gonna do is I'm gonna write down the line M. So part 3, we have got line M. Okay, this is line M. what line M does is it has passed through, sorry, this is R, it passes through P, so I'm going to use mu, it is not used, right, mu, okay, and it has this direction vector minus 5, 5 here, okay, we are told that we have this direction vector here, and passes through P, P would be 0, 1, 2, so that would be 0, 1, 2 there, 0, 1, 2, and this is actually mu, real value here. Okay, now then what we're going to do is actually I am going to just when m equals to L, okay, I'm just going to equate both of them because I'm not too sure whether they're intersecting, which point they're intersecting. I hope they are intersecting. So this case is 3 minus 4, 7 plus lambda minus 1, 3 minus 2. So I'm just equating both of these lines. I'm taking this line equation here, L equals to M. Then what we're going to get is actually from here, let's see, mu. So it's 0 plus 3 mu equals to 3 minus lambda. 1 minus 5 mu equals to minus 4 plus 3 lambda. And 2 plus 5 mu equals to 7 minus 2 lambda. Okay, so you just write down what is given at the top and so on. So this is what we get. Rearrange them and we'll see whether from GC we can actually get whether we are able to have a unique solution for this equation here. And if have, then we are pretty much safe because they're intersecting. So this is plus 2 lambda equals to 5. Okay, so GC. So here what we're going to do is just abs and go to Pauli simultaneous equation. Then we're going to do a simultaneous equation solver, and we have got three equations and 2 unknowns. Okay, great. So this is the one. I'm going to clear it, and I'm going to put this as 3, 1, 3. So 3, 1, 3, and then negative 5, 3, negative 5, negative 5, 3, negative 5, and after which we have got 5, 2, 5, 5, 2, 5. Okay, then we're going to solve it. So this is 1 and 0 from GC. So from GC, mu equals to 1, lambda equals to 0. So hence, lines M and L are intersecting. Okay, this is important. So once done, the intersecting point would then be this intersecting point here that we drew just now. This is important because once we got it, it will be quite straightforward already. So the intersecting point intersection. So name it. Maybe name it as I will name it as A. Oh, there's no A. Okay, great. So A. So just substitute this into any of the line equation. I'm going to sub into mu 0 into this. So this is 3, negative 4, 7. My goodness, is this point here. So it's actually this point here. Is this point that we're looking at. Okay. So it passes through this point. This is just this point 3, 4, negative 7. I'm not sure. I couldn't see it at the start, but anyway, that is the point there. So what we're gonna do? we're gonna then find this line of equation here. So we can actually just find this here. So the reflection line will pass through the intersection point here, and it passes through this mirror image. So typically they will ask for the mirror image. Okay, this is a line of reflection. Okay, because if you reflect the orange line, and the purple line is actually the mirror here. Okay, this is mirror. So this line here will then be the reflected line, right? This is the one. So I'm gonna just the line of reflection, hence the line of reflection will passes through A and P prime, which is what we found just now. P prime, which is actually 2, 3, 4. Okay. P prime, which is actually 2, 3. P prime, 2, 3, 4. There you go. So once done, what we're gonna do is line AP prime, linear reflection. Okay, it will be R 3 negative 4 7 plus lambda. We already have lambda, right? I already used lambda and mu, so I'm going to alpha is already used as well. I'm going to use gamma. AP prime. So the direction will just be A to AP prime, right? So this is 2, 3, 4 minus 3 negative 4 7. This will be negative 1 7 and negative 3. There's negative 1 7 negative 3. Okay, so that is how negative 1 7 and negative 3, yeah, that's how we do this question here provisionally. Of course, this you can just use P prime as well, it's fine. Okay, so if you have any questions or comments at all, please let us know. Keep practicing and I'll see you in the next question.